This is Math Man Eddie, back with another topic from a standard Statistics 1 course. In this video, we're looking at a topic which is called discrete random variables. Let's take a look at the definition of a discrete random variable, and then we'll do a few examples. So here is a definition of a discrete random variable. First it says, a random variable is a numeric description of the outcomes of an experiment. So it's a numeric description of outcomes. It's called discrete random variable if the random variable meets one of these two conditions. Namely, there's only a finite number of values that the random variable can take on, or there might be an infinite sequence of values. Let's take our first example. This example says we have a spinner, and we're going to do an experiment called spin this dial on the spinner. Now, there's only three possible outcomes, 1, 2, 3, and we're going to let x equal the dollar amount of each of the outcomes. So x is a variable because it could take on different values. It's random because we don't know what the spinner is going to land on. And it's discrete because there's only three possible outcomes. Now let's take a look at this spinner, because this is a very special spinner that I've designed specifically for this video. It has three regions, and region 1, region 2, and region 3, and it has a spinner, of course. And this spinner is designed so that the probability of landing on 1 is 0.15, and 30% of the time it lands on 2, and there's a 0.55 probability that it'll land on 3. This could be shown by the different amount of area on the spinner. Okay, so that's what the spinner looks like, and now we're going to take a look at something that's called the expected value. So right down here, I have a little condition here which these probabilities have to meet. Now, this is called a probability distribution. It shows a distribution of probabilities along the x outcomes. And notice that if we add up all the probabilities, the sum is 1. That's one condition to be a valid probability distribution. And also all the probabilities are between 0 and 1. So this is a valid probability distribution for this random variable. Now, here is our first question. Very interesting, like I said, about expected value. What's the expected value of this spinner? In other words, sometimes when we play this game, we end up with a 1. Sometimes we end up with a 2. So the question is, if we played this game many times, what would be the expected value? We have a very simple definition for expected value, and we could write it as the expected value for this random variable, or the mean of this random variable, and it's very easy to compute. We take a outcome value, multiply by the probability, do that for each of the outcome values, add them up, and that will be called the expected value. So what I did here was I developed a little table in order to do these computations. We have a column for the x value, the probability, and x times the probability. Alright, so it's very easy to do this. We take x times the probability, x times the probability, x times the probability, and then add these values together. Now our result is this. The mean of this expected value, here's the formula, is equal to 2.40 or in our case, since we're playing a game, if you land on 1, you make $1. If you land on 2, you make $2. If you land on 3, you make $3. So the expected value is $2.40. Now what this means is if you play this game over and over and over, the average value or expected value is $2.40. You notice that we never win $2.40 if we play the game only one time, but the average over a long number of times playing this game is $2.40, and that is called the expected value. Now, question number 2 is, what's the standard deviation for this random variable? So we know that there may be a mean, and there must be also a standard deviation. Now the standard deviation has a formula a little bit more complicated than the formula for the expected value, but it's a formula that we're somewhat familiar with, because what we're doing here is taking a square root. Normally we'd do that for standard deviation, and then x minus the mean is a deviation. We're going to square the deviations and then multiply by the probability of getting that particular outcome. In our case, we're going to use mu equal $2.40, which we computed just a moment ago. So to do this, we need to set up a bigger table. We have our 2 first columns like we had before, and then we're going to do the deviation, square deviations, times the probability. Now this is a little bit of arithmetic we could do, and what we end up with is this result right here. So we're taking 1 minus the mean, squaring that value, multiplying by the probability. When we do all this, we will add up this column right here, and when we add that column up, this is called the variance. It's not called the standard deviation because we haven't taken the square root yet. So the variance is 0.54, or we could think of it as 54 cents. So the mean is $2.40. The variance is 54 cents. Now to get the standard deviation, then we'll take the square root, and so our result here is the standard deviation is about 73 cents. So on average, we would win $2.40 if we play this game over and over and over, $2.40 per time we played the game, with a standard deviation of 73 cents. Let's go on to question number 3, which would be our last question. And this question says, with the spinner, what's the probability that you win at most $2? So we have to take a look at our spinner again. And you know, basically from here, sometimes we win $1, sometimes 2, and sometimes 3. So our problem says, what's the probability that you win at most $2? And so we have to figure out what does that really mean. So at most 2 means we win either $1 or $2. At most 2. So what we're trying to do is computing the following probability, which is very easy to do. We need to get the probability of 1 plus the probability of 2, and that comes right from our table. Probability of 1 and 2, add them together, and the probability is 0.45. So to summarize that, we find that the probability of winning at least $2 is 0.45. And this starts a new problem, actually. What's the probability of winning at least $2? At least $2 means we win $2 or more. Again, we would pick that up right from the table, and pick up the values for probability of 2 plus probability of 3. So there's an 85% chance that we would win at least $2. And we're signing off with this video. Look forward to another video on specific topics in Statistics 1.